Our goal is to create an app that allows you to input all of the foods that you've eaten in a day in text format or audio format and convert that into a list of foods that you've eaten along with their nutrition facts and their aggregated totals. This is going to make food tracking a lot easier for people, and we're going to build that here. To get started, open up your favorite IDE and add a virtual environment. You can generate one however you like, and this is where we're going to install all our dependencies. So the first dependency we want to install is Django, since we're going to be building a Django application. The next step for us to do is to go into our settings.py file and scroll down to the database section. And within our databases section, we want to replace what's already existing because it's requiring us to use some SQLite database. But in our case, we want to use PostgreSQL. So replace the engine with PostgreSQL, change the name to your name of your database, your username, make it your own username and password, and set the host to localhost and set the port to 5432. That is the default port. Next, we want to create our model file. In this case, we have one model, which will be our ingredient list. So we'll create a models.py file and then create a class called ingredient. What we'll do with this ingredient is we'll give it a name, we'll give it all of the nutrition facts such as total fat, saturated fat, cholesterol, carbohydrates, protein, fat, fiber, serving size unit, etc. So that way we can get all of our nutrition facts put into an ingredient model and then preload our database with that model. The next step is to create a new script called USDA.py. And what this will do is it will fetch all of the ingredients that we care about from the USDA database one at a time, get the individual nutrition facts and all the properties we care about, and put them in a list so that we can preload our database. So we're going to create a function called getUSDANutrition. We're going to pass it an API key and a food name, and we're going to iterate through all of the foods that we pass it in. Within this script, the goal is to get the median data for each food. And what we'll do is whenever we fetch a food, we will get the first 5 foods that we get from that database, find the median data for each of our nutrition facts so we can get a well-rounded number. And then whatever the median is, that's going to be our source of truth for each of our food items. The reason I'm using the median is that there are some foods that you ask, let's say you want whole eggs, but then it returns back like fried eggs, omelet, sunny side up, etc. So we want to avoid the high value items. So the median is our best bet. If we do the mean, then the values could get skewed. And we want to be able to do this across all the food items we ask it for. In our main function within this script, what we want to do is we want to keep a list of all the foods that we get from the USDA database and get all the data for each of the foods that we pass in. And in this case, food names, we can just create our own list. You can create your own list of 100, 200, 300 items. And then for each item, it's going to get the first 5 foods from the request. And it's going to get the median of all the nutrition fact data and then put it into the list. And it's going to do that for each one. So this request will take quite some time. And afterward, we're going to save this data to a CSV file. So that way we can preload our database with all of the nutrition data for each of the foods that we pass in. In order to create our actual database and import all of the ingredients we got from the USDA, we need to use Homebrew to start our database. So we're going to call brew services PostgreSQL database, and we're going to create our user and alter its role. So that way we can give the user all of the permissions to create a database and modify it, as long as we're connected to it and we're authenticated. So that's why we need to create the user, dbuser1 with an encrypted password, and then alter its role to allow it to create databases. And then we need to create the database in question, which we'll call it dbtest1. And we'll grant access and privileges to that database user. And after that, we need to call Python manage migrate and Python manage make migrations to actually do the migration work. And as you can see, we've created all of our entries, and now we can actually see all of the entries within our Django application. Next, we'll create our ingredient serializer. And again, there's some boilerplate code you need to add to make sure that you can serialize the ingredients objects from the database. And here we'll start going through each of our dependencies and adding them in. Again, don't worry too much about these dependencies. It's just specific towards my own project. But if you want to learn more, you can look up the documentation and read in depth about what each framework provides. Next, we need to create a class called IngredientListCreateView and give it a ListCreateAPI And so within this, we create a query set, get all the ingredient objects, and use our serializer we just created in our serializers.py file. Here, we're going to add a URL pattern that includes the URLs we're about to create. So here, we want to create urls.py inside our food diary app. And this is going to contain one URL that matters to us, which is our API/getIngredientsList. So we'll create a URL patterns and pass an ingredient slash, and the name of it will be ingredient list create. And so we'll go to our main app and add this URL pattern that we just created. And we're going to set it at /API. So it'll be API/ and we'll pass in the include, which we actually need to import from Django.urls. But the idea is that we're going to include from the food diary app.urls because it doesn't know where this URL exists unless we include it. And finally, we need to go to settings.py and add the REST framework. Otherwise, it won't work. And finally, we need to run Python manage run server, and this will run our server at the local host. And then we need to add API/ingredients in the URL. And we'll be able to see all of the ingredients that we just imported from the USDA database into our CSV file, and from our CSV file into our PostgreSQL database. And now our Django app is serving us the database.